Hello, today I'm going to go over free response question 7 from the 2016 AP Chemistry exam. Question 7 is a 4-point question, and the topics covered include acids and bases, titrations, reading markings on burettes, and significant figures. So question 7 reads, a student is given a 25 milliliter sample of a solution of an unknown monoprotic acid and asked to determine the concentration of the acid by titration. The student uses a standardized solution of 0.110 molar sodium hydroxide, a burette, a flask, an appropriate indicator, and other laboratory equipment necessary for the titration. Now part A reads, the images below show the burette before the titration begins, below left, and at the end point, below right. What should the student record as the volume of sodium hydroxide delivered to the flask? Okay, so to find the volume of sodium hydroxide added, you have to subtract the final measurement minus the initial measurement. So the final measurement is right here, and this is the initial measurement. So let's do the final measurement first. So when reading from burettes, you have to read from the bottom of the meniscus, which is this curve here. Right. As for the volume, we need to find the most precise measurement. So in this case, what we can confidently say is this is 37.3 milliliters, right? But then you have to add one estimated digit after it, so you have 37.30 milliliters. That's the final. Now for the initial, same here, we read from the bottom of the meniscus. Here, we can confidently say that this is 5.6 milliliters, and then we can estimate that to be a 5. So this is the initial, 5.65 milliliters. Now, to find the volume, you subtract 37.30 minus 5.65. Now we have to be careful of sig figs here because this is a lab-based problem. So for subtraction, the sig fig rule is you round the answer to the least number of places to the decimal point of any number in the problem. So since both values have measurements with 2 sig figs after the decimal point, then the final answer should have 2 sig figs too. So once you put this in the calculator, you get the final answer of 31.65 milliliters. And that is your final answer for part A. So if you have the final measurement correct, you'll get 1 point for this part. Part B says, based on the given information in your answer to part A, determine the value of the concentration of the acid that should be recorded in the student's lab report. Okay, so to determine the value of an unknown concentration or volume in a titration experiment, use the titration equation. MAVA is equal to MBVB. So here we're given the molarity of base, which is 0.110. You're given the volume of the base. Here we solve this in part A. The volume of the acid is also given right here. 25 milliliters. So now we have to find the molarity acid. So again, once upon molarity acid times, I'm going to convert the volume into liters, 0.025 liters. And that is equal to the molarity of the base, which is 0.110 molar, times the volume of the base, which is 0.03165 liters, right? And after you do your calculations, you should get the molarity at acid is equal to 0.139 molar. And that should be your final answer. So for this question, if you have the correct setup, you should get the correct molarity, and this will give you 1 point. So going back to this equation, the reason this works is because if you have a titration curve, right, at the equivalence point, it is where the moles of acid is equal to the moles of base, or the moles of hydroxide, is equal to the moles of hydronium. So this is how we can set them equal. So this equation here works because in the problem it's stated that the unknown acid is monoprotic. So what monoprotic means is that in solution, this can only yield one equivalent of H plus per liter of solution, let's say. If this is diprotic or triprotic, say if we had an acid like sulfuric acid, right? First, it will dissociate once, but then it will dissociate again. So here we can see one molecule of sulfuric acid will yield two equivalents of H plus. So this equivalent concept is known as normality. And normality is just defined as the number of equivalents of hydronium or hydroxide ions present per liter of solution. So the equation here is NaVa is equal to NbVb. And to find N, you just multiply the molarity of the acid over the base times the number of equivalents it has. So in the case of sulfuric acid, you multiply the molarity of sulfuric acid by 2. But since you can multiply them right away, people usually don't think of finding normality as a separate step. So you can just multiply the two equivalents by the molarity, and you can go back to using this equation. Now for part C, it reads, in a second trial, the student accidentally added more sodium hydroxide to the flask than was needed to reach the endpoint, and then recorded the final volume. Would this error increase, decrease, or have no effect on the calculated acid concentration for the second trial? Okay, so if more sodium hydroxide was added, then it would mean the final value that the student recorded back in part A, which is this would be larger. So if this is larger and the initials stay the same, then this value will be different. This value will actually be higher. So if this value is higher, well, let's see what it will do to the calculated value. So if we go back to the dilution equation or the titration equation, we can rearrange this. So it's the molarity acid is equal to the molarity base times the volume of the base divided by the volume of the acid. And then we're just going to copy our setup. So what the question is saying is, if this value here increase, what will happen? Well, mathematically, if this part increased and the volume here stayed the same, then the molarity of the acid will go up. So for the explanation, you can write something like the error would increase the calculated. It's important that you say it's calculated because it's not the actual molarity of the acid, it's just what you've calculated using the lab data. Calculated acid concentration, because well, now you can mention what equivalence point is at the equivalence point. The moles of base, moles of acid. Well, base and acid, I mean OH minus and H plus. Base acid. So if there's an increase of NaOH, then it will lead to a greater calculated concentration of acid. So that would be a valid explanation. If you wrote that the error will increase, you get +1. And then if you provide a valid justification like this, you get the other point. And for justification, you can also refer to this mathematical example here, and that would be correct. So if you got all of this, you'll get the full 4 points on question 7. So that is it for question 7. I hope you learned something from this video, and thanks for watching.